Welcome to this course on Elements of Mechanical Engineering. My name is Atchuta Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering. Currently, we are in the fourth module where we are studying different machine tools. In this lecture, we are going to see some interesting operations that are related to lathe machine. They are facing and boring operations. Now, let us see what is a facing operation. Facing operation is nothing but it is done in a lathe machine. In the previous lectures, we have seen what is a lathe machine and how it is operated, and what are the functions of the lathe machine and how multiple operations can be done on a lathe machine. Now, in this lecture, we are going to see how this lathe machine is used to manufacture different machining processes. Now, the facing operation is one of the important operations that can be performed on a lathe machine, and in machining can be used in two different areas: facing on a milling machine and facing on a lathe machine. So the operation facing can be done on two different types of machines, that is one lathe machine and the second one is milling machine. So facing can be done on a milling machine also. As of now, we are studying the lathe machine. We will study how this lathe machine is going to do the facing operation. So facing on the milling machine involves various milling operations, but primarily face milling. So that is all a different criteria. But on the lathe machine, facing is commonly used in turning and boring operations. Other operations remove materials in way similar to facing. For examples, planing, shaping, grinding, but these processes are not labeled by the term facing. Okay, so we have to understand that the facing operation can be performed on multiple machines, but on lathe machine, the facing operation is done in a different way. That means facing operation can be done very easily in the case of lathe machine. Okay, whereas in other machines like milling, the facing operation is very tough when compared to lathe machine, but it is not that much of tough. Okay, if we compare the facing process on lathe machine and milling machine, the facing is very easy on lathe machine. Okay, we have to remember the terminology: facing, lathe machine, milling machine. So facing is the process of reducing the diameter. Okay, we have seen other processes like taper turning, boring, etc. and drilling also in the previous lectures. So facing itself is a process which is used to smoothen the surface of the cross section. Suppose if this is a cross section, if this is a bar, a cylindrical bar, where if I want to make this surface smooth, I have to do the operation called facing. Okay, where I will make this surface, this cross-sectional area will be made smooth. Okay, so this is how we can change the smoothness of the surface so that we can use it for multiple applications. Now, this lathe is used widely for doing this operation, that is facing operation. Let us see how it works. So, as we know that the workpiece will be attached in the headstock, where it will be rotating at a higher speed. This is headstock, and here chuck is there. Okay, and then we have workpiece. This is workpiece, and then we have different cutting speeds can be given by this headstock. Okay, and then we have here this part is called chuck. Okay, this is called chuck, and chuck is nothing but it is a tool holding device or a workpiece holding device which is used to hold the workpiece in place. Okay, this is connected with the help of spindle to the headstock, where we all know that headstock is a device where it will make rotations possible. So headstock itself contains a lot of gears, motors and other parts attached, which will make the entire headstock spindle and chuck part to rotate. Okay, whenever we attach a tool into the chuck, so the workpiece is also rotating. So in this lathe machine, workpiece is rotating. So whenever we keep a tool, so generally we keep the tool on the tool post and workpiece in the chuck. So this is workpiece and this is tool. So this tool, when it is advanced or it is kept in contact with the cylindrical rod, so it will remove some material because it is moving at a higher speed, rotating speed, and we are keeping this tool near to the workpiece so that it will remove some material. Okay, so see here, this tool will remove only the cross section of the workpiece. Okay, it will not remove the length. Okay, it will not remove the diameter. It will not decrease the diameter. It will only make the surface smooth. Okay, so this is how it is done. The facing process is done like this. So see here, we can give both the feed and depth. Mostly we will give feed. That means here the workpiece is rotating. We will keep this tool in this direction. We will touch the tool to the workpiece. Whenever we touch the tool with the workpiece, what happens? Some amount of material is removed. And if we want to remove, initially, I will draw here. Initially, I will touch the workpiece at this point. Okay. So this is cross-sectional area of the workpiece. I am keeping the tool here. So this is the tool. So initially the tool is kept at this point. It will try to remove the material at this area only in circular path. Okay, in circular path it will remove the material, and whenever I want to remove some more material at this inner location, like inner circumferential area, if I want to remove some more material so that the surface will be smoothened, then I have to move the tool in forward direction. That means I have to give the feed. So I have to advance the tool in forward direction so that it will remove the material in a circumferential manner. Okay, in circular manner it will remove. Okay, finally it will go to the center. Okay, this is how the facing operation is done. So one design consideration we should keep in mind while designing the particular metal object. When I want to use the metal object in a lathe machine for doing the facing operation, I have to keep in mind some important design considerations. They are like, I have to make a cylindrical object only. I cannot face a rectangular cross-sectional object. I cannot do that because here if a object is kept on the chuck, it will be rotating at higher speed in rotating motion, clockwise or anti-clockwise. We can change both directions. So whenever we touch the tip of the tool, it will try to remove the material from the workpiece. So when the workpiece is rotating at high speed, it should be cylindrical in cross section. It should not be in other cross sectional shapes. Even though it is in other cross sections, it will be converted into cylindrical. Suppose if I have a rod of a cross section, hexagonal cross section. Okay, if I have this hexagonal cross sectional area of a bar which is attached into the chuck, and I try to do this facing operation, what happens? It will try to convert this hexagonal bar into cylindrical bar because it is rotating at higher rotating speed. We can do, or we can convert this into rotating cylindrical object shape. Okay, so the design should be mostly in cylindrical, or it should be very close to cylindrical shape, whereas while we doing the operation, it will be converted into cylindrical. Okay, so it will be converted further into cylindrical shapes. So see here, we have some parameters here. So this is all the explanation for the facing operation, and then we have to study some parameters. So here D is the depth of cut, or we can say this is the width, how much we are decreasing the facing process. See, initially the workpiece is up to here. Okay, now when I'm doing the facing operation, I have removed some amount of material, and finally it has reached this final dimension, where the difference in the dimension is taken as small d. Okay, small d is the difference in the dimension I have removed by the operation called facing operation. Now we have seen everything here. So this is chuck. Cutting speed will be given by the headstock, and chuck will be connected to the headstock with the help of spindle. And then we have workpiece. So workpiece is nothing but it is a device that is attached into the chuck, which is rotating at higher speed, and then we have tool which is attached to the tool post, and then we have to give two kind of motions here. One is feed in order to advance into the circumferential area, and depth is to give to remove the material along the length of the workpiece. And then we have machined phase. This phase is the machined phase in this particular operation. Whereas in turning operation, what is the machined phase? We have both machined phases, like this one, this length of the workpiece and the cross-sectional area of the workpiece. Both of them will be the machined phases. But the phasing operation particularly is done to reduce the length as well as to to reduce the length by keeping the diameter constant. We do not change the diameter of the workpiece. We only change the length of the workpiece by doing this phasing operation. So this is how the phasing operation is done. And then we have, when we go to the next slide, so let us see some important aspects which are to be kept in mind while doing the phasing operations. So the phasing on lathe uses a phasing tool to cut a flat surface perpendicular to the workpiece rotation. So we have seen in the previous slide, the tool should be kept perpendicular. That means it is not perpendicular, but it is perpendicular to the axis of rotation. Okay, it is not exactly perpendicular, some inclination is there, but when we compare this with the axis of rotation, the tool is almost perpendicular. So it should be kept in that direction in order to remove maximum amount of material. A phasing tool is mounted into a tool holder that rests on the carriage of the lathe machine. So whenever we want to do phasing operation, we have to keep the tool on the tool post. So the tool post will touch and cut the workpiece in the required manner. We have to keep the tool, only a single point of the tool must be touching the workpiece, not the more surface, like line surface should not be in contact with the workpiece. Okay, only the tip of the tool has to be in contact with the workpiece. And then a phasing tool is mounted in the tool holder which rests on the carriage of the lathe. We all know this. The tool will then feed perpendicularly across the part's rotational axis. It spins in the jaws of the chuck. So the tool will advance in the feed direction, and we will keep that in a particular area, and after that it will keep on rotating. That means if the tool will keep on removing the material from the workpiece, and after that we have to give depth. That means we have to advance the tool into the workpiece center so that it will remove more amount of material. Okay, a user will have the options to hand feed the machine while phasing, or use the power feed option. So while giving the depth of cut, there are two options. We can give it manually by looking at the cross section very carefully, without losing any dimensions. We have to do that with very carefully, or we can give the feed with the help of power feed option also. Power feed option is now modified and automated, and now it is also called as computer controlled feed. Okay, we can use a computer to give the feed to this particular phasing operation. And then for a smoother surface, using the power feed option is optimal due to a constant feed rate. So when we use automation for giving the feed, so it would be more appropriate and it will be more optimal because it will give a constant feed rate to the cylindrical object. Okay, it will give constant feed rate. While when we want to give the feed rate manually, we have to make sure that the feedback is given. That means the depth of cut is given very gradually. We have to increase it gradually so that no vibrations will be seen in the workpiece and the tool, and it should be in a slow and composed manner. Okay, we should not give sudden jerk movements which will break the tool or the workpiece. Okay, so these are the processes or the steps which we should follow while doing the phasing operations on a lathe machine. And then when we go for some important parameters that are related to phasing operations are feed. So if you want to know how the feed is given in the case of this facing operation, the feed should be given in the direction perpendicular to the workpiece axis. So the feed should be given perpendicular only. That means we have to give the depth of cut. Okay. And then we have to see that length of the tool travel is equal to radius of the workpiece. So how much length the workpiece, the tool has to move. Suppose if this is a cylindrical bar, so its cross section is cylindrical bar, this is in front view. I have to keep the tool here. So this is the tool where I have to keep. I have to move the tool in this direction. I have to give the depth of cut. So the length the tool traveled is equal to the radius of the workpiece. It is not the diameter. So the diameter is from here to here. Okay, this is diameter. So radius is half of it. So half of it is radius. So what I should do is, I have to start at this point. The tool has to touch initially at this point and it has to move in forward direction so that it will go up to the center point. Because the workpiece is rotating circularly, we can simply remove the circumferential material when we advance only up to the center of the workpiece. Okay, so this is how the facing operation is done, and the length of the tool travel, the value is equal to the radius of the workpiece. And then when we see the depth of cut, so depth of cut is in direction parallel to the workpiece axis. So when we want to give the depth of cut, it should be given parallel to the axis. If this is the axis of the workpiece, we have to give the depth of cut in axis parallel to the rotation of the workpiece. So what is depth of cut in this operation is, if we move in horizontal direction, if we move the tool in horizontal direction, we can remove more amount of material. That means we can reduce the length of the workpiece. And this is the length. Okay, we can decrease the length of the workpiece so that we can get more precise shape. Okay, we can reduce the length here. And then depending on how much material needs to be taken off, a machinist can choose to take roughening or finishing cuts. So depending on how much amount of material to be removed from this workpiece, we can select a rough surface or a smooth surface that has to be created on the workpiece cross section. Because always remember, facing operation is done on the cross section only. We have to remove some material initially and then we have to make the surface smooth. Okay, we have other operations which can make the surface smooth, but we can use some other operations like a grinding or honing operations, etc. They are used for making the surface smooth. So before going that, if we want to remove only a smaller amount of material, we have to do this machining process very slowly so that we will get a smooth surface finish. But if we want to decrease more amount of material, we have to do it fastly. We have to remove the material more initially, and then finally we have to keep some dimensional accuracy. Then we have to make only a little changes. Only small amount of material has to be removed slowly. Then we can get more smooth surface when compared to hard surface. So facing will take the workpiece down to its finished length very accurately. So we have to be very careful that when doing the facing operation, we have to keep in mind that the facing operation, it will reduce the length of the object. Okay. So if we do not use this process carefully, or if we do not perform this operation carefully, what happens? The length of the object will be reduced. If we go on giving the depth of cut, that means if we go on moving the tool in the length direction, what happens? More amount of material will be removed and the length of the object will be reduced. So this is very bad, because we have to see that the length should not be below the actual given dimensions. We have to do the facing operation, however, but when we want to remove more amount of material, we have to do the facing operation fastly, or else we have to do it slowly so that it will not remove the excess material from the workpiece. Even though some plus or minus values will be taken always in order to machine. While we are doing machining process, some errors will be there. Some human errors will be there, which may lead to dimensional inaccuracy. That is why we have to give some extra values. That means we have to, suppose if I want to make a cylindrical bar of length 5 mm, I will always prefer to have 5.1 mm, because I will send the information to the manufacturer or the machining operator to machine a cylindrical rod of a dimension 5.1 mm, so that even if some errors happen, I will get finally about a 5 mm workpiece. Okay, this is how we have to always give the dimensional safeties, which will be covered by some errors. Okay, and effectiveness of facing operations on the lathe are speed and feed. Okay, speed and feed. If you want to give, or if you want to prepare an effective facing operation, the effectiveness particularly depends on the lathe speed and feed. So we know what is feed and speed. Speed is nothing but it is the rotational speed of the headstock of the lathe machine with which we are rotating the workpiece, and then feed is nothing but the depth of cut which we are giving when we are doing the operation. So based on these two, we have to make the operation very effective. Okay, the tool facing operation has to be effective with the help of the speed and feeds only. And the material hardness also depends. So whenever we want to do the facing operation on a harder material, like harder workpiece is taken, then we have to keep in mind that we have to use a harder tool. That means we have to use high speed steel tool in order to do operations on the very hard material. And the cutter size is also taken into consideration. And then how the part is going to be clamped. We have to see that the workpiece should be cylindrical in shape. At least it should be closer to cylindrical shape. And this object, the workpiece, it has to be smaller than the size of the chuck size. Okay. So the workpiece should initially be inserted into the workpiece. So it has to be less than the actual size of the workpiece. Otherwise, we cannot use that particular lathe machine to do the any kind of machining operations. Okay. So these are the important aspects and the parameters we should keep in mind while doing this facing operation. And then let us move to another operation which can be performed on a lathe machine. So this is called a facing operation. So facing operation, this is boring operation. So boring operation itself indicates it is the process of enlarging a hole. Suppose I have a process called, which we have already discussed in the previous lectures. This process is called drilling. So drilling is a process where we have to make holes into the workpiece. So when we want to make holes into workpiece, we have to see, or we have to make sure that the tool, the drilling bit, has to be lesser in size than the actual size required. Okay. Suppose if I have to make a hole in the workpiece that is of diameter 5 mm. So the hole diameter is 5 mm. I have to use a tool, that is drilling bit, of diameter 4.90 only. Why do we need this? Because when we are making holes through a workpiece by using a drilling bit, so we have to make sure that it should make holes, but the holes made are very rough. Okay, because we are removing the material from the workpiece itself. So suppose if this is a workpiece, if I want to make a hole at the center, when I touch the tool, when I touch the drilling bit on the surface, what happens? It will try to remove, it will try to scrape the material out. Okay, when the material is scraped out, and the material will be, it is called as chipping. The chipping or the chips will be formed, and these chips, while forming, they will create a very rough surface at the inner surface of the hole. They will create very rough surface. The surface is not smooth inside the hole. Why this happens? Because we are using a tool which is very hard and it contains sharp edges which are very large in size. Okay, the drill bit cross section has a very thick cutting surfaces, because of which we will get a very rough surface inside the hole. Okay, we have a workpiece, we have made a hole, but the inside surface of the hole is very hard and it is not smooth. Okay, we have to do some more smoothing operation or finishing operations in order to make it useful, or in order to make a 5 mm bolt, 5 mm diameter bolt to fit into this hole. See here, we always choose a lesser size diameter of the drill bit. Why? Because it will make the drill bit to remove out of the workpiece after the process has been completed. We can easily remove the workpiece. We can easily remove the tool out of the hole. Why? Because when we are doing the drilling operation, the tool will enter into the surface and it will go into the depth of the workpiece. So, when the operation is completed, we have to remove the tool safely. So, that is why we have to give some more clearance with which the tool can be easily removed. So, I will always choose a 4.90 diameter of a drill bit, which is eventually it is as per the standard values. I have to write 5 mm on its surface. Okay, the drill bit will be notified, or it will be written as 5 mm drill bit only, but its actual dimension is less than the 5 mm diameter. So that is why we have to use a 4.90 mm diameter drill bit for making a 5 mm hole. Now, while using this 4.90 mm diameter drill bit, I can get a hole of dimension 4.95. So, I have made a hole of dimension 4.95 mm. Okay, this is the highest value the drill bit can drill. Okay, that is the maximum capacity. It cannot drill more than that. Now, what I have to do, I cannot use a drill bit of exactly 5 mm of size. Okay, so 5 mm size will make a bigger hole like 5.05, which is not useful for me. That is why I have to use a 4.90 mm drill bit, which will give me a 4.95 mm of diameter hole. And this diameter hole, it has to be undergo some other operations like boring operation. The boring operation has to be done in order to increase the surface smoothness of the hole, and also it can increase the dimensions also. Okay, so see this, boring is used to achieve greater accuracy of the diameter of the hole and can be used to cut tapered holes also. So what is a tapered hole? If this is a cross section, if I make a hole through this body like this is a normal hole. I simply remove the material in this direction and I can form a hole. But if a tapered hole is like this, it has to be in a tapered direction. So it will be, the dimensions will be varying. So what happens? How can I make this? So I don't have a drill bit which can actually drill a taper hole. Okay, all the drill bits will be rotating in the machine and they will be performing only cylindrical holes. Okay, they can perform a flat cylindrical holes only. They cannot perform a taper hole. Then we have to use this boring operation or boring tool in order to make this taper. Okay, we will simply, this is the tool. In this picture we can see this is the tool and this is its side view and front view. And this tool, it has to be kept in a inclined manner in the tool post so that we will get a taper hole. Okay, so this boring operation can be done for mainly to increase the diameter, of the hole, to improve the surface finish, and then it can be used to do some special operations like taper turning. Taper turning operations can be done. Okay, so these are some of the operations that can be performed. These are the applications of boring operation. Okay, boring operation itself is an operation, but it has multiple applications. Depending on the type, we can use it in a multiple way. So boring can be viewed as an internal diameter counterpart to turning, which cuts external diameters. Okay, so the boring operation can be used for internal cutting only. That means it can be used to enlarge the hole to make surface smooth, and we can increase the we can do the operation like taper turning. And then there are various types of borings that are possible, and the boring bar may be supported on both ends, only work if the existing hole is a through hole, or it may be supported at one end if the hole is a blind. We have two types of holes. Let us see that. First one and second one. If the hole is only up to some distance, suppose this is a workpiece, I have made hole only up to this level. So this is called blind hole. This is called blind hole. If I make the hole throughout the entire workpiece, that means it is open on the both sides. So I will cut the entire material through the thickness of the workpiece. Then it is called a through hole. Okay, this is called a through hole. So, and this is called a blind hole. So through hole and blind hole. Depending on the type of hole you are boring, we have to make sure the tool is holded on the both sides or it is holded on one side. Okay, it depends on the application. So there are different types of boring applications. Line boring. In line boring, we have it implies former. That means the line boring itself will be done on the front side. And then back boring. Back boring is the process of reaching through an existing hole and then boring on the back side of the workpiece related to the machine headstock. So there are two types of boring operations. One is line boring and back boring. Suppose if I have a workpiece and I have a hole here, if I do the boring operation at this area, this is called line boring. If I want to do the boring operation by entering into the workpiece and I have to do the boring operation at this area, so then it is called a back boring. So back boring is the process of reaching through an existing hole and then boring on the back side of the workpiece. Okay, I have to go through this hole and I have to bore on the back side of the workpiece. Then it is called back boring. And then lathe boring usually requires the workpiece to be held in the chuck and rotated. So whenever we want to do this workpiece, this lathe machine, but the boring operation can be performed in lathe machine, which is held in the chuck and rotated. So we all know that workpiece is always rotating in the lathe machine and the tool is fixed. Okay, the tool is attached to the tool post. So this boring tool is also attached to the tool post and we can do the boring operations. As the workpiece is rotated, a boring bar with an insert attached to the tip of the bar is fed into the existing hole. So whenever we want to do the boring operation on a lathe machine, we have to fix the boring bar. Okay, and the tip of the bar is fed into the existing hole. This boring bar is nothing but the boring tool which is attached to the tool post. And let us see some more important points regarding boring operation. For most of the lathe boring application, tolerance greater than 0.010 inches or plus or minus 0.25 mm. So this much of tolerance has to be easily given. Okay, so the boring operations, they can make cuts of this dimension. Previously we have said 4.95. It can go from 0.05 to 0.25. Okay, it can remove this much thickness of the material. And tolerances from there down to 0.13 mm are usually held without special difficulty or expense, even in deep holes. When we want to make deep hole reaming or deep hole boring, we can go up to 0.13 mm. Okay, by doing this operation. And the surface finish which we will get by this boring operation is ranges about 8 to 250 micro inches. And its typical value ranges between 32 to 125 micro inches. Okay, so the surface finish we can get from this operation is 8 to 250 micro inches. And then the limitations of the boring in terms of its geometric accuracy and hardness of the workpiece have been shrinking in recent decades as the machining technology continues to advance. In the olden days, we used to have some boring tools which are not that much efficient in creating a smooth surface. But nowadays, most of the machines are automated, and because of this automation, we can get more smooth surface Not only automation, we can get more advanced tools. We can get more harder tools, because of which we can remove the material and we can get better surface finish. And then, for example, new grades of carbide ceramic cutting inserts have increased the accuracy and the surface quality that can be achieved without grinding. So without the help of grinding, we can actually use the grades of carbide and ceramic cutting tools for getting better surface finish. So generally, if we compare the operations, first drilling operation will make hole. So drilling operation will make hole. After that, it is sent to boring operation, and after that it is sent to some operations like honing, and finally it is sent to the what we called grinding operation. So in this manner, we can get a smoother and smoother finish depending on how much smooth we want to attain, how much smoothness we want. We will go to another process one after the other. So here, grinding process will give you the highest surface finish, but because of the advancement in the technology with the use of carbide tools and ceramic cutting tools, we can get more surface finish, which is almost close to grinding. Okay, so that is all for this lecture. We'll meet in the next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.